I just woke up today and was greeted by my window unit air conditioner being dead. And I woke up hot. I thought something was strange about how hot I felt with having an air conditioner. I shouldn't have been that hot. So, sure enough, it was dead. Now, so far, I tried playing with the reset button and the test button that comes on the switch. I read the instructions. Supposedly, you're supposed to unplug it, press reset, plug it in, press test. The reset button should pop out when you press test. And then you press reset one more time to make it turn on. So that's like a testing procedure for the built-in fuse system to that thing or whatever. Everything looked to be working and the light came on it. But just to make sure everything was okay, I plugged my phone charger into the outlet that the air conditioner plugs into, and the phone charger started charging my phone. So the outlet's not dead. It's getting power to the outlet. So now we have to figure out why the air conditioner, I mean, it makes no sound. It's not like a humming. It's just dead. So we have to try to diagnose this now. I think this is a common problem, and so I think this is going to be a great YouTube video. I'm just going to film as I go and talk out loud. I've never done this before, but hopefully my electronics knowledge combined with the knowledge I got from watching one AC repair video and having researched how AC air conditioners function in general, I think all that put together, I should be able to do this fix. And what's nice is it's not blowing cold air, it's just dead. And so that's an electrical problem for sure. And so I should be able to do that with no problems. Whereas like if it were a freon leak or something, that might be harder to detect for me. But I think electrical should be fairly straightforward. Hopefully. So I kind of don't want to take it down from the window. It's all duct taped in. So I think I'm going to try to take the front panel off. So front panel removal. I got Phillips head screwdriver here. There's a screw here. Take that off. This has been like my favorite window unit I've ever bought too. I've been using it year round for I think about 2 full years. I haven't used it in the winter because my room is so well insulated and all the vents are blocked off for soundproofing reasons that I have to have air conditioning year round. With all the computers I have running in here, it gets too hot even in the winter. It's like a server room. The heck? Okay. I'll take this thing off. I can't really see why nothing's coming free yet. Oh, there we go. You just gotta yank on it a little bit. There! Whew, it's dirty in there. Right off the bat, I'm just going to go ahead and vacuum that front. I don't know how it got so dusty. Next. Well, I see one little screw, which might affect the control panel. Goodness, that thing does not want to turn. There, I got it. You just gotta push hard and then turn. Oh, looks like if you squeeze and then pull, these tabs come undone. Yeah, there's tabs on the sides of it. Okay. Wow, I can see all kinds of stuff inside this box when I look in there. All kinds of stuff. Okay, this is earth. This gray wire is earth, right here. And this is coming out of this main cord. So you got live, neutral, and earth on an AC three line thing. Earth is just meant to be connected to all of the metal chassis of appliances so that if a live wire were touching the metal chassis, it wouldn't, if you pressed the metal chassis with your skin, electrocute you touching like the outside of the appliance, because earth is connected to it. And if a live wire touched the appliance anywhere on the inside because it came loose, that would create a connection between the live wire and the chassis, the metal chassis of the item, which is connected to earth, and so that would complete a circuit, and live wire would flow through the chassis into earth and set off the breaker, because it'd be flowing unrestricted, really high speeds, and it would immediately pop the breaker. So the minute a live wire came loose in the chassis, it would set off the breaker. So that's what this gray one does. Then the other one are neutral, the black one, and white, which is live. And the white live, I traced it to the capacitor, which is right here on the bottom. It rests inside this in the bottom. And neutral runs to, let's see, Yep, neutral runs to right here, I believe. Wait, let me make sure. No, neutral actually runs to the left. Yeah, neutral runs to this line right here on the left of the bottom switch, right here. So anyways, the main thing is I can start testing any exposed metal for current with my multimeter. Actually, let me switch cameras. Well, maybe not. So let me get out the multimeter and I'll start testing things. We can actually see a lot of stuff from this point of view. I think we can actually solve it without taking it out now. Like, we got a lot of access here. Alright, when I test 0.2 volts AC, didn't it just say 14 volts AC? Whoa, 120 volts AC. Maybe it's just the switch went bad. It's live, like it's getting power to the power switch, which is this bottom switch here. I just touched bare metal at the bottoms of these switches. You can see these are just like two plugs plugging into either side of the power switch here. And there's a little bit of metal exposed on the bottom of each, so I put my probes on the exposed metal and I set it to AC and it marked 120 volts. So these are live. There's actually water in this thing. That shouldn't be there. So maybe I don't know, it looks burnt to me. Check this out, guys. This is This is good stuff, man. Do you see the burntness right here? Right there, it looks a little burnt around the back of the power switch. You can see it right there. I see some burnedness. It could have been water that got on there. So I think it's just a bad switch, maybe. Now, when the switch is switched on, I think it shorts these two, completing their circuit. So I'm going to try to unplug those two from the switch and short them together. Huh? The AC unit just came on, guys. It just came on. Holy crap, it came on. Just from wiggling this around. That's insane. So it is something to do with the power switch. Ah! I cannot get this other plug unplugged. I'm gonna have to pull Hercules style. I'm feeling real good though, guys. This shows me that this is going to be a successful repair. This thing just came on. It is very wet inside this control panel. Good grief. That cannot be good. Okay. You know, I wouldn't mind just bypassing the switch, honestly, to an always on situation. If you get my drift. In other words, if I want the AC on, it's always going to be on just by being plugged in general. I mean, then again, that is pretty ghetto. Wait 3 minutes before restarting? Why would it say that? It's kind of a red flag that it's this hard to pull this thing off. I mean, I am yanking on it. Oh my gosh! I put about 80 pounds of force on it just then, which most people can't even do, and it still won't pull off. That is ridiculous. Oh my gosh. I just saw a spark. And I smell smoke. So, what happened there is, remember I told you Earth is connected to the chassis? My tool must have been connected to the chassis and then to Earth from that live line, enough to cause a spark. Now, whether that spark blew the fuse, I don't know yet. So, well, there's one way to test. Multimeter again. If it blew the fuse, it's not that big of a deal. 122 volts. AC. Okay, it did not blow the fuse. So the circuit breaker allowed that quick spark. Because sometimes appliances will, like motor related appliances, to start up will draw more than the allowed amperage of a household fuse for just a split second. So fuses don't trip immediately for that reason, to allow that. Otherwise, fuses would be blowing up constantly. So they'll allow it to go over for just a brief second like that. What I want to try to do is remove the power switch completely from the front panel. My confidence is super high now because I know I can fix this in a multitude of ways at this point. Alright, it was a faulty power switch situation, basically. Alright, so I got the power switch out now. We can look at that later. For now, I want to try to hotwire it, so to speak. Well, we'll come back to that. Let's just analyze the power switch. We'll take our time, do it right. We'll see what could be the issue with that first, before we get crazy with anything else. Okay. Taking this back to here. Alright. So we got our power switch. Let me get my multimeter over. Alright, this is what I was talking about with the power switch. Let me show you guys. Look at the burning. Look at the discoloration along the base. That looks really bad. Especially the leftmost one right now. Looks pretty darkened. That could be breaking electrical connectivity. So I think maybe just scraping it off for a while might be enough. Just cleaning it. Maybe spray on some electrical connector spray that mechanics use. I've got some of that spray. I think it's called like... I don't want to say... I was going to say white lithium grease, but it's not that. It might have had lithium in the name, I'm not sure. I'll go get it. But yeah, it's stuff that, like, if you have a bad electrical connection on a car, they tell you to spray it on there. So I'm just scraping the contacts, basically sanding them right now with an X-Acto knife. I see dust coming off them. Oh wow, a lot. There's a lot of crap on it. When you scrape hard, you realize, wow, the metal's way shinier beneath this crust that's not even really detectable to the eye until you start scratching hard, and then you see, like, wow, there is a film of white stuff over this whole thing. And I think that's all it was. Just like battery terminals in a car get calcified, I think that's what was on these terminals, calcification. That can be all it takes to have a bad connection. And once the connection got bad enough and water got back in there, that was enough to make the switch not work. But I think the switch actually will still work. I think it's just these prongs need to be cleaned real well. Yeah, this prong on the left is real nasty. This stuff matters. And I think if I put on some of that grease stuff, the electrical fittings spray that mechanics use, I think if I put that on after this, it will protect it from happening again. Like, it prevents oxidation. I'm also going to scrape away the burnt sign on the casing if I can, so that in the future repair I will be able to not see that, since that could throw off my diagnostic on what's wrong next time something happens, if there's a next time. I mean, I assume there will be if I use this air conditioner for many more years. Eventually I'll have to fix it again, I guess. I thought it would be like a bad capacitor in there. I'm glad it wasn't, because that would have been probably, well, first of all, not very accessible, and 30-40 bucks probably to buy one, a replacement one. It's that giant can style capacitor. Yeah, so these contacts are just really calcified. I guess water didn't get on this though, because maybe just being moist in there though caused the calcification. I could say that. Perhaps that was a factor. But I don't know why there's discoloration then. I'm not sure. Maybe there was a bit of a short circuit situation going on, maybe. But not like a full-blown one, because if that were the case, the fuse would have blown somewhere in there. And the fuse couldn't be blown because I just saw the thing come on when I wiggled the connectors that are connected to this switch, this on-off switch. So it can't be that the fuse is completely blown. Alright, I'm going to run a continuity test, so you just switch it to the diode symbol, which is this little arrow pointing to a T, like uppercase T, is the diode symbol, and these three blue things look like noise making or volume or something like that, and that's exactly what it does. It makes noise. So you switch it to that, and then you press this, and this thing will switch from diode to the noise marker. And what that does is when you stick these two together, it beeps. That's a continuity test mode. So I believe this is still switched to on. So when I press it against one and then the other, it should beep. Oh, it's not beeping though. Alright, well, I guess, I don't know. I mean, I thought that's how a switch works, that it completes the connection. So I'm not sure what that entails. That test wasn't necessary anyways, but I'm kind of surprised that that test didn't prove more useful than that. That's weird. Okay. I think it's gonna work now when I plug the things back into the switch. Crap. Oh no. I can see calcification inside the connection point of the wire itself too now. I can't touch anything metal while I touch this. Because it's live. I'm doing all this live. Because YOLO. I know the risk. I'm willing to get electrocuted for science. But you should have it unplugged when you do all this stuff. I mean, I think having it live, though, is kind of nice. Like, it popped on and that told me so much earlier. What? I bet we blew the fuse down below when that spark happened. Maybe. I don't know. Because it's dead now. I thought it wouldn't be by this point. Unplug it. Press reset. Plug it. Press test. Press reset. Okay, that's the protocol there. Yeah! Alright, I think this switch is still bad. I think the continuity test should have worked. I also think if I connect a wire to those two things, if I hotwire it, that it will work. That's my prediction. So, I'm putting that idea to the test. Yes, it's working. But it's running through a much too thin jumper wire. But by shorting this to this, it's on. Okay. It's a bad switch. This stupid little switch is frickin' bad. And my continuity test on it should have beeped when it was switched to on. This thing's not working. This little switch is the culprit. So I'm gonna begin reassembling. I know how to turn it on now from the outside. just with like connecting, shorting those two. So this is live, and this one's ground, or that's incorrect. This one's live, and this one is neutral. Connecting live and neutral completes a circuit. No. Wait, how does this work? Okay, I don't even know, but completing them turns things on. That much we can say. I guess it could be live and live. I don't know. I mean, it provides continuity to everything going on here. That's what we can say. So this was a successful repair as far as I'm concerned. I'm starting to put things back. From the outside, we'll be able to jump everything. Okay, let me just start out by reconnecting. I'm just trying to think if I've got a switch. It's got to be a like a light switch type switch. I kind of just assume order one, but you know what? I'm gonna cover those electrical end contacts in electrical tape, so I don't zap myself when I have to pull them together. Because they gotta come together for me to fit them both through the switch hole. There. Actually, just covering one, well, I'll cover them both. Okay. So now we've got the two wires that went to the two sides of the switch exposed. And we've shown that if you stick a jumper wire, you know, just a wire with two exposed ends into each of those terminals, that doing so causes them to turn it on, completes the circuit. So we can try to find another switch. We could try to fix the switch. Or we can just twist those wires together. I feel like people complain when I don't do the job like professional style. So I'm kind of scared to just bypass the switch, because you guys will complain that I didn't complete it right. I know you guys, I don't trust you. You guys want the job not only done, but done quote unquote right. It's always a catch. Well, I could look for a switch in my electrical scrap box, I guess. Wouldn't hurt. You could use the switch from an old power supply for a computer. Those have the right kind of switches, that on-off. You could use the switch from an old power surge protector. Those have that big, thick on-off switch. I don't know, maybe you guys would think that me fixing the switch itself is more impressive than replacing it. Maybe I should do that. It might not be that hard, actually. It probably just needs to be cleaned out on the inside. It's probably burnt up. So I'll do that. That's going the extra mile for you guys. Hey, what's up, Demented? I'm trying to fix the switch to my air conditioner. This was a faulty switch. And rather than replace it, I'm seeing if I can actually fix the switch. Taking this repair to the next level. Today's the worst day to lose your air conditioning. It's plastic for days. Why is there so much plastic on this housing? It's insane. gosh, it's never ending plastic. Okay, man. Yo. Get that much Finally, I see something non-plastic. Crap! Ugh. I woke up today hot as heck because my air conditioner blew out, and my room is isolated from the central air of this house because I soundproofed the room and I blocked all the vents off. Because the vents carry sound, so you can't have a soundproof room with vents. So this room becomes like a furnace with no air conditioner. Heat comes in but can't go out. Whew. Okay, now we're getting somewhere. Aha! Oh my gosh, that's super weird. Look at this. This switch just has a little copper noogie. It's so weird. It's hilarious. Oops. And it pulls out and there's a spring on it. The spring fell onto my stomach. I gotta find that. Here it is. Yes. Fell into my shorts. Okay, so there's a spring activated copper head. Interesting. And that goes to a contact plate. What's up, Chris? I'm not gonna injure my wiener. Okay, so this prong gets bridged by this plate. Oh, that scared me. And this plate touches this thing, which touches the other prong, completing the circuit. It's a bridge. My switch stopped working. You gotta clean all the contact points, for one thing. Everything's like got some burnt crust on it. It's all calcified. I knew my continuity test should have worked on the switch. I don't know why I doubted myself. A switch's job is to either close a circuit or open it. And now that I know what the inside of a switch looks like, I can say that with confidence. There's nothing fancy going on. All it does is short circuits the two wires connecting them. And when the switch is off, they're not connected. It's that simple. That's all a switch does. Wow, there's a chunk of molten plastic. Yeah, there's all kinds of melting. This thing melted the heck out of itself. Oh, why would the switch melt, you have to ask, though. I think it was drawing too much power. More than the switch could handle? Maybe? Which could mean there's a short circuit, or it could mean maybe the motor got jammed up, like the fan wasn't spinning, it got caught up on something. And so the motor was trying to draw power like crazy because it wasn't moving. And it drew too much power through the power switch, causing the internal housing of the switch to melt, which created very little electrical contact on the little metal parts that need to connect within the switch housing. And then with time, a little bit of calcification added on to the fact that a lot of the little metal parts are coated now in plastic, and suddenly you have no more electrical connection. No more electrical connection means no power flows through the switch. No power flows through the switch means no power gets to the machine. No power gets to the machine means this machine doesn't turn on anymore. Yeah, there's all kinds of plastic deformation inside this housing. I got plastic pieces all over me from molten plastic that is in places it shouldn't be. Yeah, I'm thinking that there was enough calcification in molten plastic that things just weren't connecting anymore. The electric couldn't flow through. There's no way this thing's gonna work again. That's BS. At least I kind of know how switches are made, sort of. But yeah, this thing's done. That would take me obscene amounts of time to try to fix at that point. It's just a little beyond what I think it's worth doing. Because that part is probably like 45 cents or something crazy. Let me see how much it would be. AC on-off switch is what I just googled. I want to do eBay. Huh! Some switches are like $12. Good grief, that's ridiculous. Price plus shipping lowest first. Always. These are some giant switches here. I'll show you guys what I'm looking at. This kind of switch has actual screw here, so you can put the wire through between the screw and this terminal and clamp the wire through just using a screwdriver. That's kind of interesting, which makes me think this switch might be huge, but there's actually no indicator to scale, like if they had a little dime next to it, you could have an idea of how big this is, but this is 250 volts. I'd want a 120 volt. I should probably indicate 120 volts, but yeah, I think I'll do that. AC switch 120 volt. Nah, it's more work to go to AC hardware and get one. I can turn the air conditioner on. I'll show you guys how I'll turn it on until the switch arrives. I'm just going to hotwire it. The switch is just a convenience thing, really. It's called a rocker switch. Maybe I'll try that, rocker switch. What's throwing me off is they have 4 pins or 3 pins. I tell you what. Why 4 pins rocker switch? Dang, that's a huge switch.
Well, I did buy it from Amazon, but in truth I didn't wire it up properly. Though we'll come to that in a moment. I'm happy to give a demonstration of how it should be done.
That's too big, man.
It's a 4-pole illuminated rocker switch, handling AC voltage of 125 or 250 volts. So clearly it's intended for mains use.
I do not want that kind of switch. I do not want that kind of switch. Oh my gosh. 2 pin. Alright, I need to just indicate 2 pin. Most of them have 3 pins. I don't know why. Robot's coming well. No, I need a 2 pin. You can't just change the wiring and ignore some pins. I need a 2 pin. Plain simple as that, because it's designed for 2 pins. This is it, boys. Here it is. 99 cents and free shipping. If you go to the hardware store, it will be like probably like $3 plus your gas, and probably at least 30 minutes of your time. Whereas this, you just set it, forget it. Alright, just bought it. And I get 2 of them actually, so I don't know, it'll be kind of nice to have another AC on-off switch that's like a little mini one like that. These seem really convenient for a lot of projects. You know what? I got an idea. Oh my gosh, dude. This is gonna blow your minds. You picked a good day to watch me. I'm actually doing interesting stuff today. So inside this switch, the terminal comes up in the center and on the left. You see that circular thing on the left? That's where this terminal comes up. So you see this part and this part. They get bridged when the switch is on by a little bridge piece, which we already threw away. I'm going to bridge them. So I'm going to solder a connection between the right and left terminal. Or actually, I could even do that out here. That's even easier. So this will be an always on switch, in other words. Yeah, it did get burnt. So alright, I need wire next. Alright, I'm using wire from a transformer. I want to start it on fire to get rid of all the crap that's on it. I gotta turn this stupid fan off. Well, maybe I'll blow it this... No, I don't know. I gotta turn this fan off for a second. Okay, that'll burn me now. That's why I have two lighters. One to hold on for a while, and then it can cool while I use another one. So, the wire... Look at that, it just started on fire. This wire is coated. It's coated in lacquer. See it start on fire? Look at that. It's all black now. So my window unit air conditioner died because its switch went bad. I couldn't switch on anymore. So until I get a new switch, which I just ordered from China, I'm taking the old switch and I'm gonna make it an always on switch. Now, if you're doing this from home, you can hot wire those two wires any way you want, or just wait for the switch to come. In other words, I could cut open the insulation on the two wires and just twist them together, and that would turn it on. You can do it a ton of ways. I don't even know if the way I'm doing this is the best way, honestly. But you gotta pick some kind of way. Maybe this wire wasn't the best either. I could get better wire than this. This is transformer windings wire from a big screen TV I took apart for parts. And it's all sealed with lacquer, which I just burned away, and I'm carving away the burnt stuff to expose all the good copper. It's impossible to say what the easiest way to do this would have been. Oh, I don't really know. Alright, I'm just gonna solder it right on. Put a little flux, Kester 186 flux. Use my helping hand to make them be by each other. Oh, here we go. Okay. Let that cool. And alright, so we got wire now on this terminal of the switch. Solder to it, and then we're going to wrap it around and solder it onto this terminal so that the two terminals are shorted. And then we'll just plug the switch in and the AC will be on forever. Always on switch. I just made extra wire so that it would be like that. 2 loops so that more current could flow. And I'll solder the 2 loops all together. Because I don't want it sparking or anything because it's not letting enough electric flow. The idea behind this is, like, rather than take off the terminals on the wire of the AC unit, we keep them on and we just plug them back into an always on switch now. Because once we get our new switch, we'll just be able to hot swap it directly onto the new switch and be done. Whereas if you start stripping wires and taking off insulation and stuff, you're going to have to put all that back on again when the new switch comes. So this will just have this bad switch be always on, and you just plug the prongs right onto these two little prongs. And when the new one comes, boom, just plug it into the new one and you'll be good. You'll be able to switch it off again. So until the new one comes, if I want to turn it off, I have to unplug the air conditioner, which is fine. The plug's under my desk though, so that's not the most convenient, but I'll have AC again, so that's got me happy as can be. Okay. So now we've got everything's shorted now into one big donut, both sides, so electric can flow plenty between the two prongs. I'll just plug it in and we'll for sure have the AC unit turn on. I think this will pop right on now. And we'll be live. Our AC will work. So I'll show you guys. It is live right now. let me put away everything on my lap. I still gotta be careful. You always have to be careful when you work with things live. And I choose to work with things live because I like the risk of electrocution, and I like to have the instant feedback of whether things are working. But for most sane people, that's not how you do it. So I'm not recommending that for sane people, just for crazy people who don't mind the risk, which is substantial. Okay. So we're just going to plug in one wire here. And I'm covering the whole thing in electrical tape now, just to prevent anyone from like accidentally getting electrocuted who doesn't know what's going on. They're trying to shut this air conditioner off. Like if I left the house and forgot to shut it off, and they're like, this switch looks odd, and then they touch it and get electrocuted. I can see my dad doing that. We got AC, na 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 na. The power flickering was once I got one wire close enough for... Okay, air is a conductor of electricity, but not a very good one. So if you can get two wires close enough, the air will bridge the gap, and you'll see a spark as the electricity passes through the air and completes the circuit. So that's why you saw a spark at first, and then as I continued to move it closer, then they actually physically joined. And then I plugged it in. Okay, so that's it. I fixed my air conditioner. You guys can't say nothing. Look at that. So it's just like ready to go. We got the two terminals coming out, and we'll just pop that off and pop in the new one and push the button in, and it will seat and it'll snap in. It's black though, but that's okay. And it'll snap back in the hole, and everything's done. You don't have to open up the air conditioner or anything when that comes in. So that will ship over like the next couple of weeks or whatever. It will eventually arrive. And we did it. I fixed my air conditioner. Man, that feels good. You know, that was such an emergency thing, it being hot as heck outside and all, that I didn't even bother to add it to my to-do list. So I can't cross it off my to-do list. If something's an emergency of that magnitude, the to-do list isn't even relevant anymore. Like, there is no to-do list. Fixing that becomes my entire life's purpose. And to-do lists imply you have many things to do and you're going to prioritize them. I didn't have many things to do. That was the only thing I would ever do until that problem is solved. And that even trumped eating, drinking, sleeping. everything. And now that that's done, now my life can return to me and I can have a to-do list again.